Hey guys, welcome to yet another video of my series on parallel programming in Python. So in the last video we saw the issue with sharing the data between the processes in multiprocessing, and now we are gonna see what are the solutions for it, and the first solution is called shared memory. So basically multiprocessing module provides us two types of objects called arrays and values which can be used to share the data between the processes. So array is an array allocated from the shared memory. So basically there is a portion in your computer memory which we can call as a shared memory, a region which can be accessed by multiple processes. So in that shared memory we create a new array or a new value. So these array and value are not your basic Python data structures, they are something different and defined in the multiprocessing module itself. So let us try to see that. So let me make it result. So now I am defining my result as multiprocessing dot array. So in the array I have to give the type, so I can use I or F. I am using I, which means int values will be put inside it, and the size, so you have to give the size. So basically it is related to a C programming style array, so you have to give the size at that at the same time, right? So I'm just putting 4 here. So I want my result list to be able to store 4 objects, right? So it is not your simple list, it is much more related to a C or C++ style array. So this is what it looks like right now. And I'm also just for understanding creating a new I'm creating a new value called square sum. Square sum is equal to multiprocessing dot value, and it will be storing an int value. Okay, again, so I have created an array object and a value object for myself. And now what I'm going to do next is create a process p1 equal to multiprocessing dot process, in which I'll be calling a function. Let me call square underscore list function. Okay, which will be taking 3 arguments. Now it will be taking my list, it will be taking result, and it will be taking square underscore sum. So actually I'll now be passing these result and the square sum values to my function by using this process arguments. So let us see how we can do that. Target is equal to square underscore list, and in the arguments I'm gonna pass my list. So I haven't defined my list yet, so let me define my list is equal to 1 2 3 4. Okay, so my list and result and square sum. So these are the 3 things that I want to pass as the arguments to my process. And okay, so these are the basic definitions that I have just created. And right now in the square list, let me do something. In the square list I'm gonna do for let's say idx comma num in enumerate my list. So I'm using enumeration so that I can get the index value of my list object as well, so that I can do something like this: result idx. So basically this is a C style array, as I told you, so I cannot use the append thing. I will have to use the indexing way of assigning the values to my array. So result idx is equal to num into num. So this is how I'm going to do it. And finally also I'm going to do square underscore sum. So now for accessing the values of the value object, you have to do squares value dot value. This is a property of each value object in multiprocessing module. So square sum dot value is equal to sum of result. So this is how I am doing the things here, and that's it. This will be my function, and now I'm just gonna define some things. And now p1 dot start and p1 dot join. So now what I want to see is that I have defined some variables in my main process. They are getting changed in the function called by the child process, and I want to see if I will be able to get those changed values in my main process. That is my main agenda behind it here, right? So let me just run my process. I have run it, I ran it, and now let us try to see the value of result. Okay, so there is result dot value, I think result dot value. Okay, so there is something else. Let me start by checking square square sum dot value. Okay, so the square sum value is 30, which is actually 1 plus 4 plus 9 plus 16, the squares of these values. So that is working fine. Let me just try to see how do I get the value of the array. So I think it is for I in range 4 print result I think this is how it work. Okay, right. So look at that. I get 1, 4, 9, 16. So basically this is again the C style thing. So in C or C++, what do you do to get the values of elements in your array? You make a loop, right? So that is what you have to do here again as well. So I get 1, 4, 9, 16. So in this way I was able to achieve what I wanted. I was able to make a program in which I can do any kind of changes to my objects which were defined in my parent process, changed in the child process, and those changes were getting reflected back in my parent process. So that is what we wanted, and we were able to do that using the shared memory technique. And just for more understanding, this is how the shared memory looks. You have got a shared memory in your CPU. So we made two objects in a shared memory. Now process 1 can also access the shared memory, process 2 can also access the shared memory. So in this way this is working. So this is how the concept of shared memory works in multiprocessing, and you can use it when you want some kind of communication or want to share the data between the processes in your multiprocessing program. So this is how you do it. So that's it from this video. Thanks for watching.